today, but they are a good one. So when we're dealing with properties of exponents, when we're raising something to a power to a power. So if I look at this, I have x to the 5th squared. That means I'm taking x to the 5th times x to the 5th. That's what I'm doing, right? When I'm squaring something, I'm multiplying it times itself. What was the rule that we got last week? When I'm multiplying, what do I do to the exponents? I add them. So this would be x to the 10th, right? That's what the rule is. I add the exponents, I get x to the 10th. If I do the same thing on this one here, I have 2 squared times 2 squared times 2 squared. Third power means I multiply it times itself 3 times. What do I do to the exponents here? Add them. So I have 2 to what power? 5th? 6th. Okay. M cubed times m cubed times m cubed times m cubed. 1, 2, 3, 4 times m cubed. Into the what? 15th. So, however, do you really want to write it out like this every single time? Do you see a relationship between this number and these two numbers? Between this number and these two numbers? Between this and these two? You're multiplying. Yeah. 5 times 2 is 10. 2 times 3 is 6. 3 times 5 is 15. When you raise a power to a power, you multiply the exponents. Okay? When you raise a power to a power, you're multiplying the exponents. Okay, when you raise a power to a power, you're multiplying the exponents. The way I like to think about this is that when you're multiplying two things, you add the exponents. When you're raising it to a power, you multiply the exponents. What you do to the exponents, I like to think of it as one step down to what you're doing to the actual number. I'm multiplying the numbers, I add the exponents. I'm raising them to a power, I multiply the exponents. That's one of the ways I try to remember how to do it. Bless you. Okay? So once again, this is a new rule. Now, if you look at the other problems, they're not quite exactly the same. So we have a rule for those. If there are multiple items in parentheses, each one of those is raised to that power. So you multiply each of the exponents on whatever's inside the parentheses times the power outside. And it's only to what's inside the parentheses. And notice, very important hint right here. Don't forget your invisible ones. If we do not have an exponent that is explicitly written down, the exponent that's there is 1. It's like if I have an x by itself, how many x's do I have? I have one of them. I have a 1 out front. But we don't write the 1 because we're lazy. We don't need to put a 1 to tell me I have 1 x. If I have an x by itself, how many are there? There's 1. I don't need to put a 1 in front. Okay, I don't need to put an exponent of 1 because it means the same thing whether or not it's there. So it is unwritten that it's there. So if I look at doing this one here, I have an exponent of 1 that is there. Okay, it's an unwritten one. It's an invisible one. We don't need it, but it does help us do our problems. So the rule says everything that's in the parentheses, those exponents need to be multiplied by the one outside the parentheses. So I have 3 to the first raised to the second power. 1 times 2 gives me 3 squared. And then I do the same thing on the x's. X to the 5th squared, I multiply those two, 5 times 2, x to the 10th. Each exponent is multiplied by the power that's outside.
So how do you get 3 to the second?
Okay, because normally what do we have? What do we have here that's not written? We have an exponent of 1, right? So we have an exponent of 1. Every power that's inside gets multiplied by the one outside. Okay. Now, what is 3 squared? 9. So I do want to simplify that. If I have something relatively small along those lines, yes, please. If you have 3 squared, write that out. If you have 12 to the 8th power, do not tell me what 12 to the 8th power is. It's this great, big, ginormous number that is not worth multiplying out. But you can square 3, you can cube 4, things like that. They're small enough numbers. You get a big one? No, leave them in exponential form. Okay. So if I go to the next one, I do the same thing. Each one of these numbers in here is multiplied by the 3 that's outside. So I have 2 to the 6th power times x to the 6th power. Now, you have access to your calculators. 2 to the 6th power, 2, 4, 8, 16, 32, 64. You can figure that one out. 2 to the 6th power is 64. This is 64x to the 6th. What is my current exponent on the 2? So 1. What's my current exponent on the m? 1. So I have a 1 here and a 1 here that we don't, once again, we don't write 1s for exponents. We don't write 1s in front because it doesn't really make any difference. So what do? We multiply those 1s times 5, so I get 2 to the 5th, m to the 5th. Anybody know what 2 to the 5th is? 2, 4, 8, 16, 32. Doubling each time. When you get it all in the computer, you should know your powers of 2. Because everything's driven off the powers of 2 on computers. These computers have 2 states of being on or off. That's all they are. Everything in a computer is either on or off. Zeros and ones, ons and offs. That's all it is. In theory, you could build a computer with just a bunch of light switches. Take an awful lot of them. It'd be really hard to do because they'd all be on and off. They'd all be wired together. And it'd be a great, big, giant mess. I wouldn't want to be the one running around turning them on and off. But in theory, that's all it is. It's just a bunch of light switches that go on and off according to whatever your needs are. Once again, I wouldn't want to be the one doing it, though. Now, I know you're in a panic because you're looking at the second problem and you're going, oh, crap, what am I going to do? Well, don't worry about it. It's not a big deal. So, first one, I have n to what power?
4.
No. What's my final answer? I have n to what power?
8.
Yeah. N to the 4 times 7, which is n to the 28th power. Now, you do not have fractions on any of your stuff on your classwork, but these aren't that big a deal. And if you did have fractions, you could use your calculator to multiply them out. So this is x to the 2/3 times 1/2 power. Your 2's cancel out. You get x to the 1/3 power. And yes, fractional exponents are a thing. They are actually a very big, very important thing. I'm not sure how much we are going to use them in here, if at all. I don't think we actually do touch them in this class. I don't think Algebra 1 deals with fractional exponents. But fractional exponents are roots. That is the cube root of x. I know in Algebra 2 we do, because I'll talk in Algebra 2 and I use it in other stuff. Fractional exponents are a big thing. Okay, this is similar to some of the problems you're going to be doing on your homework today, or classwork, I should say homework, but it's classwork. You have different parts that you're trying to simplify down. You do it one step at a time. Biggest mistake students make on these is trying to do everything all at once. This y cubed that's out front, I'm not going to mess with it. I want to deal with this first. Anytime I have a power to a power, I want to deal with that first. The y cubed out front doesn't change. I'm not doing anything to that yet. Okay. What I am going to do is I am going to do the next part. I have y to the 5/2 times -2. 5/2 times -2. That ends up being -5. So I end up with y cubed times y to the -5. Don't try to do everything at once. You can't necessarily go in order across the problem. Okay, I didn't touch the y cubed. Take care of the more complicated portion first. Now I go back to, I have y cubed times y to the -5th. My rules say that, I'm multiplying. I add my exponents. 3 plus -5 gives me -2. Now, am I finished? No, 90% of the time when the teacher says, am I finished, are they actually finished? No. I'm not allowed to have a negative exponent. What do my rules say about negative exponents? I put it in the denominator and make it a positive exponent. My rules say that is 1 over y squared. And that's my answer. Questions so far? When you have problems, and you will have problems similar to this, do them one part at a time. Take care of the power to a power first, and then do any multiplying, and then if you have anything negative, then move it down to the bottom. Okay, the last step you should be doing should be taking any negative exponent, moving the denominator to make it positive. That should be the last step you do in anything. Do the powers first, do the power to a power first, do the multiplying of the adding of the exponents next, and then if you have any negative, you put it down on the bottom. One step at a time, it's not overwhelming. If you try to do it, look at the problem as a whole, it can be overwhelming. I'm going to ignore this part and just do this. I'm going to ignore this part and just do this. Makes it a lot easier to get it finished. Okay. So, simplifying, raising a product to a power. Find the area of the square. Now, a note about the figure that is drawn. Many of you will be taking a geometry class next year. One of the offerings we have is a Geometry 1112, which is a geometry version of this class, which you should plan on taking. There will be a few exceptions, but pretty much everybody in here plan on taking that class. It is the best thing for you moving forward. Financial analysis will be a senior-only class starting next year. So if you're a sophomore, you don't want to skip a year of math and then go on. You're going to be doing geometry, and then you don't take the financial analysis if you don't need it for graduation using already passed. Some of you need the geometry anyways based upon your Algebra 1 foundations grades. If you have questions about anything you should be taking or anything, if you have Learning Center, talk to your Learning Center teacher, or you can talk to me or Mrs. Kersey, and we'll be glad to go bring it up with you. Okay. But if you are taking geometry next year, you should understand what this figure means. Okay, what does a little square in the corner mean? It's got a right angle. What do the little lines on the side mean? They're all the same length. That's what it means. If you see two lines in the geometric drawing that have a tick mark on them like that, that means that it's the same length. I have all four of them have one tick mark. All four of them are the same length. This is a square. 90-degree corners, all four sides are the same. It's a square. How do you find the area of a square? You take the length of one side and you square it. That's what you do. Now, none of these answers look like what I have here, so what do I have to do? I have to simplify it. I have a 1 here, distribute to 2. 5 times 1, I'm sorry, 2 times 1 gives me 5 squared. 3 times 2 gives me x to the 6th. And what is 5 squared? Oh, that's the answer. What's 5 squared? 25. So I have 25 x to the 6th. And some of you bright young things already told me it was the answer D. Uno mas. One step at a time, one part at a time. This looks extremely overwhelming. It's not if you take it piece by piece, step by step. I look at this and I go, ooh, first thing I'm going to do. I've got n to the 1/2 raised to the 10th power. What do I do to my exponents here? What do I do with the 1/2 and the 10? Yeah, I multiply them. When I raise a power to a power, I multiply the exponents. What is half of 10? 5. So that gives me n to the 5th for that part. That was easy, right? First step. I ignored the rest of the problem. I just looked at the first part. I haven't done anything with the next part, have I? Now I need to go, all right, I've got that part done. Now I need to look at this part. Got a couple of nasty things going on here, but they're not bad. I take this 3 over here, and I multiply it times every exponent, including the one on the 4 and the one on the m. Yes? Hang on. What? Yeah, I did the 1/2 times 2. So 3 to the 1st gives me 4 cubed. M to the 1st to the 3rd power is m cubed. And then here's the hard one, negative 2/3 times 3, negative 2/3 times 3. Look, those cancel. I get n to the negative 2. Piece of cake, right? You do it part by part. Don't try to do everything at once. Go, ooh, I'm going to just deal with this little part at the beginning. Now I'm going to deal with the next part. Now I'm going to put everything together into one final answer, or at least try to. So our numbers by themselves should go out front. So we have 4 cubed. You can do that on your calculator. The 4 cubed is 64. So I've got that one taken care of. Now I have n's and n's, but I should do it alphabetically and put m on there. M, there's only one m. So I have m cubed. And then I have my n's. I have n to the 5th times n to the negative 2. What do I do to the exponents here? I add them. What's 5 plus negative 2? 3. N cubed. And that is that. Piece of cake. Really, it's exponents are all about the rules. It's all about the rules. You follow the rules one at a time. And basically, you go backwards in importance from what we have here. You got a power, things distributed to a power, you raise each to a power. You have a power to a power, you multiply them. You work your way backwards. Ooh, and then I deal with multiplication. Then I deal with negative exponents. The only thing I would do is if I have anything to the 0 power, I would just get rid of it because it's 1, and I would just cancel it out anyways and ignore it from then on afterwards. But really, you just work the rules, and it's important from the bottom up from what I have here on the board. That's all exponents are, following the rules. Got the rules up here for you. You should have all the rules in your notes. This is the importance that you do them in, from the bottom up. Okay? Questions?